This lesson is about multiplying and dividing radical expressions. First, remember, the first 20 square numbers are the following. You should definitely work on memorizing all of them. I like to sing the first 10 to row, row, row your boat, such as 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Of course, you can memorize them any way you like, but you can have fun while you do it. Let's review a definition. The product rule for radicals states that the root of a product is equal to the product of the roots, such as the square root of m times n is actually equal to the square root of m times the square root of n. For instance, the square root of 5 times 7 is actually equal to the square root of 5 times the square root of 7. You can also use the product rule in reverse order. The square root of m times the square root of n is actually equal to the square root of m times n. For instance, the square root of 5 times the square root of 7 is equal to the square root of 5 times 7, which is actually equal to the square root of 35. So, you can multiply a root times a root to equal another root. The product rule can be used in a large variety of ways to accomplish many different types of computations with roots. Let's take a look. Application 1. You can simplify a square root. So if you're taking a square root of a number that is the product of a square and a non-square number, it can be simplified using the product rule. For instance, the square root of 12. 12 can be rewritten as the product of a square number, 4, and a non-square number, 3, and you break apart the roots using the product rule, and you can simplify the first term, and so you have 2 root 3. Another example, the square root of 3600. Not many people know the square root of 3600 off the top of their head. However, you could rewrite 3600 as 36 times 100, and then break apart the root using the product rule, and we all know the square root of 36 is 6, and the square root of 100 is 10, and so 6 times 10 is 60, and the square root of 3600 is 60. A neat trick to impress your friends and family. Here's another example. The square root of 14 cannot be simplified, because 14 is not divisible by a square number. For instance, you could rewrite 14 as 2 times 7, but neither of those are square numbers, so you cannot simplify the root. Here's some practice. Go ahead and try your hand at simplifying these square roots, and then proceed to the next screen. Application 2, multiplying roots. When you multiply a root times a root, you multiply the numbers and keep the root. This is simply the product rule in reverse. So root 2 times root 3 is root 6, and root 15 times root 2 is root 30. Keep in mind that the product of non-simplifiable roots might be simplifiable. For instance, root 15 is not simplifiable, and root 15 is not simplifiable, but when you multiply them, you get root 225, and the square root of 225 is 15. Likewise, root 2 times root 6, neither term is simplifiable. But when you multiply them, you get root 12, which can be rewritten as the product of a square and non-square number. And so you can break apart the root in that way and simplify the first term to get 2 root 3. Practice multiplying the following roots. Keep in mind that some of them, once you multiply, might be simplifiable. Application 3. Squaring a root. When you square a root, that is, multiply a root times itself, the root symbol cancels with the exponent, leaving you with just the number. For instance, root x times root x is root x squared, which simplifies to simply x. Here's a couple more examples. Root 5 times root 5 is root 25, and the square root of 25 is 5. Or root 12 times root 12 is root 144, and that simplifies to simply 12. You could just keep in mind that any time you multiply a root, such as root 13, times itself, root 13, the answer is always just the number. That's a nice shortcut. You can also rewrite any whole number as the product of 2 roots. So for instance, the whole number 10 is actually root 10 times root 10. Go ahead and practice multiplying the following roots. Application 4. You cannot multiply a root times a non-root. When you multiply a root times a non-root, you simply write it as a product, but the numbers do not actually multiply. For instance, the whole number 5 times the root 7 is simply 5 root 7. You just write it down. They're being multiplied. Likewise, 12 times root 3 is simply 12 root 3. Nothing more can be done. Keep in mind that when you multiply roots times roots and non-roots times non-roots, such as 2 root 5 times 5 root 7, you can multiply the whole numbers together. 2 times 5 is 10. And you can multiply the roots together. Root 5 times root 7 is root 35. And that is your final answer. Here's another example. 10 root 6 times 4 root 7. You multiply the 10 times the 4 to get 40, and you multiply root 6 times root 7 to equal root 42. That is your answer. Practice multiplying the following whole numbers and roots together. Application 5. Rationalizing the denominator. Let's review a couple definitions. A rational number is a number that can be written as a fraction of two integers, such as 2/3, 5/2, 8/1, 0/1, and the square root of 4 is rational because it simplifies to 2, which can be written as 2/1, which is also rational. Another definition. An irrational number is a number that cannot be written as a fraction of two integers, such as roots that cannot be simplified, like root 7, and expressions involving pi, like 3pi. When dealing with fractions, it is proper to write the fraction without roots in the denominator. If there is a root in the denominator, you can multiply the numerator and denominator of that fraction by the root you want to remove. For instance, we can rewrite 5 over root 3 without the root 3 in the denominator. What we do is we write down 5 root 3, and then the root 3 is what we want to get rid of in the denominator, so we multiply the top and the bottom by root 3. On top, we have 5 root 3. On bottom, notice root 3 times root 3 is actually root 9, which is 3. And now we have an expression without a square root in the denominator. Keep in mind, you're allowed to have a square root in the numerator. That's just fine. You're not allowed to have a square root in the denominator. Mathematicians have agreed not to do that. Here are some examples of rationalizing the denominator. Notice that in every case, I take the square root in the denominator that I do not want to have there, and I multiply the top and bottom of the fraction by that same root. On top, you'll multiply straight across, and on bottom, the root times a root always simplifies to equal just the number. Once you do that process, you might be able to simplify the whole numbers even further. For instance, let's take a look at this example. 6 over root 2, you multiply root 2 on top and bottom, and on top you have 6 root 2, and on bottom you have 2. Well, the 2 and the 6 simplify to become 3 and 1. So your final answer is simply 3 root 2. Likewise, the next example, 30 over root 3. You multiply top and bottom by root 3. On the top you end up with 30 root 3, and on the bottom you have 3. Well, 3 goes into 30 10 times, so it simplifies into 10 over 1, which simplifies further to simply 10 root 2. The other examples work the same way. Take a look, then go to the next screen. Here are some problems to do, and on the next screen you have the answer key.